Hey everyone, I'm Apoor. Today I want to talk about the artificial neural networks (ANNs). Artificial neural networks have become one of the most transformative technology in the field of artificial intelligence. Modeled after the human brain, ANNs enable machines to learn from data, recognize patterns, and make decisions with remarkable accuracy. This video explores ANNs from their origins to their functioning and real-world applications. Artificial neural networks are computational systems inspired by human brain. In 1943, Macaulay and Pitts created a mathematical model for neural networks, marking the theoretical inception of ANNs. In 1958, Frank Rosenberg introduced the perception, the first machine capable of learning, layering the groundwork for neural network applications. In 1980s, the backpropagation algorithm revolutionized ANN training, thanks to the contributions of Rumelhart, Entons, and Wilhelm. 2000s and beyond. With advances in computing power and large dataset deep learning techniques, ANN have achieved breakthrough in tasks like image recognition, natural language processing, and autonomous driving. How do artificial neural network works? Artificial neural network consists of three primary layers. First one is input layer, accept raw data. Second is hidden layer, perform computation and feature like extraction by applying weight and activation functions. Third layer is output layer, produces the final result such as prediction or classification. Each neuron in an artificial neural network performs computation by calculating weighted sum of their input, adding a bias term and applying an activation function like ReLU, rectified linear unit, or sigmoid. This process introduces non-linearity, enabling the network to model complex patterns. Mathematical representation of artificial neural networks. Artificial neural network (ANN) are computational systems inspired by human brain architecture. They consist of interconnected layer of nodes called neuron that process information. Mathematically, the operation of single neuron can be represented as Z equals summation from I to n and product of Wi xi plus b, where z is the weighted sum of input, also referred to as pre-activation values. N is the number of input to the neurons. Wi is the weight associated with the ith input. Xi is the ith input value. B is the bias term which allows the model to shift the activation function. During the forward propagation, this computation flows through the neural network layers, generating prediction. If prediction deviates from the actual values, errors are calculated at the output layer using loss function. These errors are then propagated backward through the network during the propagation to adjust weight and biases, optimizing the model using algorithms like gradient descents. Steps to train an ANN. First step is initialization. In this, we randomly assign weights and biases to neurons. Second is forward propagation. In this, we compute the output for a given input using current weights. Third is loss calculation. In this, we measure the error using a loss function like mean squared error. Fourth is back propagation. Calculates gradient of the loss with respect to weight using the chain rule. Fifth is optimization. Adjust weight iteratively using optimization algorithms like gradient descents. Sixth is iteration. Repeats the steps until the error is minimized or the model performs satisfactorily. Now, ANNs versus biological neural networks. While ANNs are inspired by biological neural networks, here are notable differences. Features: biological neural networks, artificial neural networks. On the basis of neurons, biological neural networks have billions of biological neurons, whereas artificial neural networks have computational units called nodes and connections, adaptive synaptic connections. Artificial neural networks have weighted mathematical connections, learning, context aware continuous learning, and artificial neural networks have task specific batch based learning. And energy consumptions, highly energy efficient, resource intensive energy consumption. So, biological neural networks have high energy efficient, and artificial neural networks are resource intensive, especially for deep models like we need GPUs and all that. Processing: biological neural networks parallel and distributed are they are fully parallel and distributed, and artificial neural networks are computational hardware. Applications of ANNs. Artificial neural networks are integral to numerous industries. First one is healthcare, medical imaging, disease diagnosis and drug discovery. Second is finance, fraud detection, stock market prediction and credit scoring. Third is transportation, autonomous vehicles and traffic predictions. Fourth is entertainment, personalized recommendation on platforms like Netflix Netflix and Spotify. Fifth is robotics, path planning, and vision systems. Artificial neural networks have transformed how machines learn and interact with the world. Their ability to mimic human-like learning and adapt to complex data has led to unprecedented and advancement in AI. While challenges like energy efficiency and interpretability persist, the potential of ANNs to revolutionize industries and improve lives is undeniable. As research continues, the possibilities for innovation seems limitless. Thanks for watching. See you soon.